In this video, since we are tasked to load 5 data values in a certain register, and we are also tasked to add them all in a single register, and we will try to solve that problem. So now we will create new project, and then we should select Atmel AVR assembler, and we will rename this project as activity 1, since this is our first task. And then we will change the path of the file, and we will choose the activity 1 to save our file, then press OK, then click next, and then in this IDE we will choose AVR simulator, and then we are also tasked to choose the atmega 32 as our device, and then click finish, and let's wait for the IDE to load. So this is the IDE where we will try to type our code, and let's expand this one, and we will use this to type in our codes about the problem. And remember that we are tasked to load 5 data values, and then we are also tasked to add them all in a single register. And after loading all the values using LDI instruction, we will now utilize the add instruction to add the values of our registers. And since we are now done with writing of our code, we will try to assemble this code in order for us to see if there are errors or no errors. And also to know what is the problem being solved, just look at the description below. And now, since the code doesn't have any errors, as you can see, the green assembly complete, no errors and no warnings, we can now proceed with the assembly and run, or the debugging mode. So this is how the debugging mode looks like, and this is our status registers, and we are tasked to monitor the CHC flags, and this is our registers, and let's try to monitor as we go on with the step info. It is observable that as we step with the LDI instruction, there are no changes with our flags. But after the first add instruction, it is observable that the S and the negative flag are turned on. However, the CHZ flags are turned off. And after the second add instruction, it is observable that the carry flag is turned on, meaning that the resulting value of the addition of the R16, 17, and 18 exceeds the B7 bits or 8 bits of the status register. And after the third add instruction, it is observable that the half carry flag is turned on, meaning that the resulting value after this add instruction has the exceeding 4-bit value on the lower nibble bits of the resulting value. And after the last add instruction, it is observable that the carry flag was turned on, and this only means that the addition of all the 5 values that we had loaded in certain registers exceeds the 8 bits of the status register, or it goes beyond the D7 bits. But also, we cannot disregard the values of the sign flag and the negative flags, as they are already turned on, and it is also playing their part in the status registers. And after examining our status registers as well as the CHZ flags, we can now reset this one, and then we can also observe the behavior of our register specifically from R16 and R20. And now, as we are stepping over the LDI instruction, we are also putting the values of the given values to us with the problem to their specific registers. And with the help of the add instruction, we can now compress all the given values in a single register, which is R16, and it is observable that the values are being added to register 16. And I guess that's it. Thanks for watching.